Hi everyone. Today we'll discuss about debouncing in JavaScript. Debouncing is an important topic with respect to interviews also. Also, it is a really important core functionality which is available in JavaScript. Also, debouncing is a software development practice which is followed by many of the websites that we come across. So, this is an important interview question which is asked by companies like Amazon, Ola, uh, Flipkart and Walmart. Another question that is asked with debouncing, along with debouncing, could be of throttling, and uh, one version could be what is the difference between these two. So today we'll cover about debouncing, and then we'll see throttling in the next coming videos. Okay. So now, what is debouncing and why is it implemented? What was the need to introduce debouncing in our software practices? Okay, so see, if we have a normal Flipkart website over here, and this is the search bar, right? Whenever we search anything over here, see, we get these suggestions over here. How are we getting these suggestions? All these suggestions come from an API call. Okay, so let us try to make a you know, a search bar like this, which fetches some results and shows us on the display. Okay, so if we try to do it step by step, see, debouncing is will be applied in this thing only in these search bar things where we. Okay, let me just first tell what debouncing is so that you get a little bit context on what we are going to do. See, over here I have this word, right? Laptop. So the complete word is laptop, right? But when I was typing LAPTO, so should the API call should go for every word that I type, or it should go only when I have finished typing? It should only go when I have finished typing, right? So debouncing allows us to do that so that we could save our expensive API calls. API calls can be very expensive and they are also chargeable and all of that. So we have to minimize all of them. So one thing that we came up with, if users the keyboard strokes are inactive for say 300 milliseconds or 400 milliseconds, then only go and fetch the API and fetch the suggestion results. Okay, so this is implemented with the help of debouncing. Okay, so we'll try to implement this thing right now, and I have let's just try to do this in code and sandbox. We'll create a new sandbox. We'll choose React and we'll name it debounce. Okay, so yeah, we'll do this, and it is loading, I guess. Uh, so okay, let's just wait for a while. Uh, just a second, guys. I should have loaded and till then I should have explained. Yeah, so it is loaded now. Okay. So okay, till the time it is loading, we'll try to get the API call which we would try to will get the API which we would call. So see, we on this dummy JSON website, I have this API. This is a API for searching recipes. Whatever query you put over here. See, let me just show you over here. If I do this, then what result would it give me? It would show me all the results which have Margareta in this because our query was about Margareta. So this works the same as auto suggest or auto complete input boxes that we have on Google, Amazon website or Flipkart websites. So we'll try to build something like this and we'll use this API. Let's just copy it and remove it over here. From here. Okay, so over here I'm putting it over here and commenting it. Okay, so this is a pretty famous coding platform and it is used during machine coding interviews as well. So auto complete. So or maybe debug. Okay. So first of all, what we have to do is we have to build an input box, right? Over where user would type whatever they want to type, right? Then whatever would be the value which would be set in this input box, we would have to fetch the data. So const fetch data for whatever query user has put over here. Okay. So this would be an async await function because we are trying to fetch an API, so we need to wait till the API call is returned to us. The response is returned to us. So const response is equals to await. We'll use the fetch function which is given to us, and we'll fetch this over till now. Okay, so right now I'm just keeping this, and maybe what if I keep a null? So if nothing is there, then it will return me all of the recipes that it has. Okay, then I'll put it inside a data variable response dot json, and I have to await the source. Okay, now I have got the result. So now I would have to declare some state variables to store the data that I get back from the API call, and also I have to have some state variables for the input. See over here, if I type something, I need to pass this thing to this, right? And then it would like fetch for this keyword, right? So I need to have a state variable which would keep track of this, and then I have to have a state variable which would keep track of the result which I will get, or the data which I will get from the API call. Okay, so one would be our query, which would be a use state initially empty. Then we would have a results array which would store all the result that we get from the API call. Okay, results. Okay, so now whenever we'll get the data, we have to set the results to the data. Now we need to do some uh, we cannot set directly set the data, but we have to see what is the response structure that we are getting. Then we have to destructure that JSON object, and then according to that we'll set our data. So I'll show you right now. Okay, see, if I just put set results is equals to data, then it would have just this recipe, and then inside it we would have this. So every time we have to access anything inside them, so basically if I have to access this thing, classic margarita pizza, anything like that, I would always have to do results dot recipes dot of 0 and then name, because this is an array, so I'm accessing the 0th element, or like that. But if I do something like data dot recipe initially only, then I can directly access the members without doing dot recipes again and again and again and again. So this type of API destructuring is really important, and sometimes this is a simple API right now. Okay, so if you want to explore, I think, well, like when I was practicing, Swiggy had their public APIs in their netbook tab. So I practiced with those, and they were like really tough because it's a proper application. So if you want to practice more and more, so I would suggest real world APIs. Okay. And also this question mark, this, what is this? This is basically optional chaining. This means if we have data, then set results to dot recipes. Sometimes it is possible that there is any API error or something, and we do not have data. It is undefined or null or anything. In that case, we would not have recipes. So null dot recipes would give an error. So to keep away that error, we are doing this optional chaining thing. Okay. Now we have to modify our so value would be whatever the query is. On change, we'll have a callback function which sets our query to whatever it is typed in the input box. Okay, e dot target dot value. Okay, so I guess yeah, this is it. And now we need to fetch, like every time I type something in this, query is set, right, using this. Now every time query is changed, I need to fetch the data, right? Fetch the data, right? So how would I fetch the data? Always remember, whenever we have to make an API call, we always do it in use effect component. And why in use effect only? Uh, it is because of the React lifecycle methods, which I would uh, tell you later or maybe in another video. But always remember that anytime we have to do an API call, we have to do it in a use effect. Okay, use effect hook. So in the dependency array, whenever query is changed, okay. So what we have to do, we have to call the fetch data function. Fetch data function. Now fetch data should take query as an input and then search only for that query. So this would add, like this would append this to the string, right? So okay, and it would pass query. So now we have to show the results, right? Okay, so how do I show the results? So I can just do a results dot map, whatever is the result, and then just use a paragraph tag, I guess, where key is putting like inserting a key on every map element is really important because React follows the reconciliation or the diffing algorithm, and like how do I explain this? Um, Maybe you can read about it, but okay, like I'll tell you in short. So basically, React follows something called diffing algorithm. Every time it has to change the DOM, it just sees all the components and whatever are the new components, it just like flips them and changes the DOM like that. So key helps React to keep track of all the components which are new or old. So like it is not proper definition, but just in in a hurry I told you. So see, we have all these over here right now because currently our query was empty. So initially use effect, whenever the component or the page is loaded, once it gets called, and then it will again get called whenever query would be changed. So initially it got called and query was empty string. So it fetched the response for an empty string, and for whenever query q is nothing, so it would just return all of the recipe names that it has. Then we set it over here and we displayed it over here. Now let's just see if we search for mango. So we get all the mango. Now let's just see about the number of API calls that we are making. So whenever we reach uh, the fetch data function, that means we have made the API call for the query. Okay. Let's just see how many times we are doing. Let's just try to reload and then see. Okay, okay. So see over here. Okay, so initially the page was loaded. So use effect was called once. Now it would be called only when query would change. Okay. How would query change? Whenever I type something and it would set the query from over here. Okay. Let me just try write mango. So see MAN, MANG, MANGO. For every word I type, a separate API call was uh, was made and then the result was fetched. So do you think it is an optimized thing to do? Like why should we call API every time user is typing? Because if I am a user, I according to me I would type mango first and then the app should go and fetch the data, right? I don't care if it's searching for MAN. No. So we have to implement this thing where if if any see over here API call, it is an expensive function, right? It is an expensive thing to do. So we should try to reduce it and not do it very often. And we clearly see a loop over here. Or so what we will do is we'll try to so over here comes the concept of debouncing. What does debouncing does is debouncing tries to reduce the expensive operations that we do by delaying the functions. How does it delay? So basically, if we have this input box, debouncing would say like, guys, wait, before making an API call, let's just try to delay the API call function by some amount of time. If the delay is successful, then try to call it. But like if I have this M and now it is waiting for maybe 3 seconds, but before that only I did this. I did ME. It will not call because 3 seconds were not completed right now. Okay. So by this it saved us some expensive API code. So this is the function of debounce. Okay. So now how do we implement debouncing? Okay. So let's just see. Debouncing can be implemented with the help of set timer. Okay. So now we have to implement debouncing. Okay. So now we have const timer is equal to set timer. There would be a callback function and a timeline. Maybe 300 milliseconds. Wait for 300 milliseconds. If the user has still not typed anything, that means user wants the result of this thing that they have typed. So if 300 milliseconds have passed, then fetch the data for this query. Okay, but maybe user is typing and they typed M. Now we are waiting for 300 milliseconds. But before completing those 300 milliseconds, user has typed another letter MA. So this timer goes null and void. And how does that go null and void? We have to clear it. Okay. So how do we clear it? A callback function, right? Clear time. Oops, this time. So what does this do is basically uh, see initially I typed MA. Okay, maybe I typed M. Okay. So now what happens is as soon as I type M, query is changed, so use factors invoked in action. Okay, so it starts a timer over here. But I type A, then immediately I type MANG. So see over here, it did not make API calls till I reached this amount of time. So how did it not do that thing? It basically it started the timer and then it was calculating time, but before that I uh, uh, pushed another keystroke. So this function cleaned up the timer. It resetted the timer to 300 and then again called the function. Okay. So this thing is really important, and sometimes we tend to forget that we have to do this also. So this thing is related to React's life cycle methods. What are React's life cycle methods? See over here. This is by React only. So see, this is React's life cycle method. What happens? What is the life cycle of a component from its creation to its unmounting, or maybe to its deletion or anything, to the time till it's not in action. So basically, whenever we create a component, it is mounted. Mounting is happening. Mounting means it is placed into the DOM tree, which means React makes the DOM tree know that okay, there is a component now, and we have to take care of it till it is not unmounted. Okay, so whenever we create any component, we have this mounting thing where the component is mounted on the DOM. Then, whenever any state change or any prop change happens, the component is updated and then it is re-rendered to display all the changes. Then, when all these things is completed, and we do not want the component anymore, maybe it was a conditionally rendered component, and if it was true, then only render the component, and now the condition is false, then we do not want that component on our DOM, so we do an unmounting of this. So when a component is unmounted from our DOM, it is very important to have all the cleanup of that component beforehand, which means we should not have any pending API subscriptions, network requests, or things like these. Okay, so and why should we do the cleanup? To avoid any memory leaks, any unnecessary state changes. Now, see, this is the thing that is important for us. It will make us understand why we need to perform this action, this return thing. Okay, see, I called a component, the timer started 300 milliseconds, okay, but I pressed immediately another. If I do not do a cleanup over here, it will still be counting, and then when the counting would be finished, it would fetch the API and update the state. But I did not want, but according to me, the user immediately clicked another keystroke, right? So logically, an API call for that previous thing should not have been made, but it was made. Why? Because we forgot to clean up the timer, and it was still running in the background, and because we did not clean the you know we did not clean the function, a state change happened on an unmounted component. As soon as we press another keystroke, this component gets unmounted, and then it will again get mounted, and all of that things happen. So if it was unmounted, then how are you doing a state change? So to avoid that warning and that what do we say, that wrong practice, we clear the timeout over here. So I hope I was able to make the things clear. So it is all because of React's lifecycle methods. And functional components have just come in picture. Earlier, when React was initially built, class-based components were only used. And like developers literally did all these component did mount, component did update. And React has very beautiful documentation on all these concepts. And like I love React documentation, and I've like read it like two times. I have already read it. So it is really beautifully explained over here, and all these things, component update, before update, did update, mount, before mount, all of these things. And I think to understand React's lifecycle methods more clearly and why this thing was necessary over here, you should go through them. And many a times we we forget to write this thing over here, and it leaves a bad impression over the interviewer because they think that we do not know React in depth. But it should not be the case because we know React. React is amazing. Okay, so this was the thing. So, okay. Yeah, so I did not show the demo, right? See, so API call went over here and so initially. Now let's just see if it is working or not. So MANG. So see, API call only went for mango and not for MAN, okay? Like, and if I do LASSI, so it only went for this. But if I am a slow typer, then so it would go. But 300, 400 is the general thing. So yeah. So yeah, this was about debouncing, and this is how it is implemented. So if anybody asks you any question related to this, you should be able to answer it because, like, I guess I was able to explain to you. Uh, so yeah, so debouncing is a really important topic also. So yeah, so thank you for listening, and I'll see you in the next video. Bye.